Welcome to the Quiznek.com podcast. With Quiznek, you can create educational content on any subject. Go to Quiznek.com and explore other quizzes and podcasts and create your own customized educational content for any subject. Welcome to the quiz titled, I Want to Learn Python Programming. This engaging quiz is designed to dive into the world of loops in Python programming. Loops are essential for automating repetitive tasks and iterating over data structures in your code. In Python, there are two main types of loops, for loops and while loops. A for loop iterates over a sequence of elements, such as a list or a string, executing a block of code for each element in the sequence. On the other hand, a while loop continues to execute a block of code as long as a specified condition remains true. This type of loop is useful when the number of iterations is not predetermined. Within loops, you can use control statements like break and continue to alter the flow of the loop. The break statement allows you to exit the loop prematurely, while the continue statement skips the current iteration and moves to the next one. Nested loops are another powerful concept in Python, where you can have one loop inside another. This technique is handy for working with multidimensional data structures or performing complex iterations. Understanding how to effectively use loops in Python will significantly enhance your ability to automate tasks, process data efficiently, and solve a wide range of programming problems. In our next episode, we will explore functions in Python, a fundamental building block of modular and reusable code. Stay tuned for more insights and practical examples to elevate your Python programming skills. Let's delve into the world of conditional statements in Python. These statements are essential for controlling the flow of your programs effectively. By mastering if-else statements, if-elif-else statements, and logical operators, you can dynamically adapt your programs to various situations. Moving on to loops, another crucial concept in Python programming. Loops, such as for and while loops, allow you to repeat code blocks multiple times, automating repetitive tasks efficiently. Mastering loops is key to working with data collections and streamlining your coding processes. Within loops, we have control statements like break and continue to manage the flow of execution. The break statement exits a loop prematurely, while continue skips the current iteration and moves to the next one. Understanding and mastering these statements will empower you to tackle complex programming challenges with ease. In Python, functions are fundamental building blocks that encapsulate code into reusable segments. By defining functions using the def keyword, you can improve the organization and efficiency of your programs. Functions can have parameters for data passing and return values using the return statement. They promote code reusability and can even be assigned to variables, enhancing the flexibility of your code structure. Today, we are diving deep into the world of Python functions. Functions are the building blocks of code that allow us to organize, reuse, and streamline our programs. Let's start with the basics. When defining a function in Python, we use the def keyword, followed by the function name and parameters enclosed in parentheses. The function body is then indented. For example, consider a function called greet that takes a name parameter and returns a greeting message. Parameters act as placeholders in the function definition, while arguments are the actual values passed to the function when it is called. For instance, in a function to add two numbers, the numbers 3 and 5 are arguments passed to the function. Functions can return values using the return statement. If no return statement is specified, the function returns none. For example, a function to multiply two numbers would return the product of those numbers. Variables defined within a function are local to that function and cannot be accessed outside of it. Global variables, on the other hand, can be accessed within a function but must be declared global to be modified. Documenting functions using docstrings is a good practice to explain their purpose and usage clearly. This enhances code readability and understanding. Python also supports lambda functions, which are anonymous functions with a single expression. They are handy for quick operations and can be used as arguments in higher-order functions. Speaking of higher-order functions, they can take other functions as arguments or return them as output, providing flexibility and abstraction. This allows for powerful and modular code structures. Practical examples of functions include creating a calculator function or processing data efficiently. Understanding functions is crucial for mastering Python, as they improve code organization, readability, and reusability. In Python, parameters and return values are essential concepts that enable data transfer into and out of functions, promoting modular and reusable code. Remember, parameters are local to the function, while return values can be stored for external use. By grasping the significance of parameters and return values, you can maximize the utility of functions in Python, enhancing code modularity and maintainability. Thank you for joining us on this educational journey through Python functions. Stay tuned for more insights into Lambda functions and their applications in Python programming. Lambda functions, defined using the lambda keyword, are perfect for short, throwaway functions that are used infrequently, enhancing code conciseness and readability. The basic structure of a lambda function is lambda arguments, expression. Unlike regular functions defined with def, lambda functions do not require a name. They are limited to a single expression and cannot contain multiple statements. The expression is evaluated and returned without the need for a return statement. Lambda functions find common usage in functional programming constructs like map, filter, and reduce, where they serve as arguments to higher-order functions. They can access variables from the surrounding scope, similar to regular functions. However, due to their brevity, lambda functions are best suited for simple tasks. For more complex functions, regular function definitions are recommended. Practical examples of lambda functions include basic lambda functions, using lambda with map, filter, and sort. These examples showcase the concise and efficient nature of lambda functions for specific use cases. Moving on to modules in Python, they are files containing Python code, including functions, classes, and variables. Modules play a crucial role in organizing code and promoting code reuse. By importing modules using the import statement, you can access functions and classes defined within them. Whether using existing modules or creating custom ones, modules help logically structure Python programs. Creating your modules involves defining functions and variables within a python.py file. This process allows you to organize your code into manageable sections and reuse it across different programs. By understanding modules, you can efficiently organize your code and leverage Python's extensive standard library. In conclusion, Python code allows you to define functions, classes, and variables for code reusability. Modules enable you to write code once and use it in multiple programs. By creating your modules and importing them into other Python scripts, you can customize functions and classes to suit your specific needs. Thank you for tuning in to our podcast on Lambda functions and modules in Python. Stay tuned for more insights and tips on Python programming. In the realm of Python programming, the creation of modules is a fundamental practice for organizing code effectively. By encapsulating functions and classes within modules, you establish a structured approach to accessing and utilizing your codebase. This modular programming approach not only enhances code organization, but also promotes reusability, a key aspect in software development. Python's adaptability shines through its ability to accommodate functions with identical names across different modules, showcasing its prowess in code organization and reusability. As you venture into developing your modules, you're preparing yourself for the intricacies of larger Python projects where modular programming is indispensable for maintaining and scaling applications. Python, a versatile programming language, boasts a vast array of libraries that streamline coding processes and augment functionality across diverse domains. Libraries like NumPy, Pandas, and Matplotlib are pivotal in domains ranging from data analysis and machine learning to web development and automation. Acquainting yourself with these renowned Python libraries not only expedites your learning curve, but also broadens your programming capabilities significantly. The exploration of popular Python libraries is not merely an academic exercise. It equips you with practical skills for real-world applications. By immersing yourself in Python and experimenting with these libraries, you unlock the potential to elevate your projects and deepen your comprehension of programming principles. Shifting our focus to data structures, let's delve into the realm of lists and tuples in Python. Lists, a versatile and potent data structure, empower you to create, access, and manipulate data efficiently. These dynamic structures are pivotal in Python programming, serving as repositories for collections of items spanning various data types such as integers, strings, and even nested lists. The mutability of lists enables seamless modification of their contents through addition, removal, or alteration of items post-creation. A fundamental characteristic of Python lists is their zero-based indexing, where the initial element in a list is denoted by an index of 0. This indexing scheme facilitates easy retrieval of elements within a list. Moreover, lists exhibit the flexibility to accommodate a mix of data types, including integers, strings, and floats within a single list. To instantiate a list, items are enclosed in square brackets and separated by commas. For instance, mylist equals 1, 2, 3, hello, 5.5. Accessing elements within a list is achieved by referencing their respective indices, like first item equals mylist. Slicing operations enable the extraction of specific segments from a list using start and end indices denoted as list start end. For example, sublist equals mylist13 generates a sublist from index 1 to 2. Manipulating lists involves assigning new values to specific indices. For instance, mylist2 equals 10 alters the third element in the list. Addition and removal of elements from a list are straightforward operations that facilitate content manipulation. Lists stand as foundational data structures in Python, offering versatility and efficiency in managing collections of items. Venturing further into the realm of Python lists, we explore a myriad of operations that can be performed on them. Concatenation and repetition are essential operations that enable list combination and duplication, respectively. Additionally, list comprehensions provide a succinct method for generating lists by applying expressions to each item in an iterable. This powerful feature streamlines list creation processes, enhancing code readability and efficiency. Moving on to sorting and reversing, let's dive into some practical examples. Imagine creating a grocery list, adding an item, and then printing it out. Similarly, you can create a list of numbers, sort it, and display the sorted list. In conclusion, mastering list operations is crucial in Python programming. With lists, you can efficiently manage data collections, execute complex tasks, and develop robust applications. Lists are versatile and can be applied in a wide array of scenarios, from basic applications to intricate algorithms. Understanding tuples. Let's explore tuples, a type of data structure closely related to lists. Tuples are immutable and are defined by enclosing elements in parentheses, unlike lists that use square brackets. Stay tuned as we uncover more key facts about tuples and how they differ from lists. In Python, there are different data types such as strings, numbers, and tuples. Tuples are versatile and support indexing and slicing, allowing you to access elements based on their position. Unlike lists, tuples are immutable, making them suitable as keys in dictionaries and sets. One interesting feature of tuples is their ability to return multiple values from a function. To create a tuple, simply place a comma-separated list of values within parentheses. For example, my tuple equals 1, 2, apple. If you need a tuple with a single element, remember to include a trailing comma, like single element tuple equals 1. Accessing elements in a tuple is straightforward using indexing, where the first element is at index 0. For instance, my tuple 0 will return 1. Slicing allows you to extract a portion of a tuple, like my tuple 1, 3, returning 2, apple. Tuple packing involves assigning multiple values to a single tuple, while unpacking allows you to assign multiple variables from a tuple. For example, A, B, C equals 1, 2, 3. Tuples are commonly used when data should not change, like when passing data within a program or returning multiple values from a function. In practical terms, tuples offer a reliable way to store and manage data effectively. List comprehensions within the realm of data structures, specifically focusing on lists and tuples. We will delve into the power of list comprehensions for dynamically creating lists. List comprehensions are a valuable syntactic construct in Python for generating lists based on existing ones. The basic syntax involves an expression for each item in an iterable with an optional condition. While list comprehensions enhance code readability, it's essential to strike a balance and avoid overly complex constructs. Compared to traditional for loops, List comprehensions are generally faster due to optimization during list creation. Understanding tuples is also crucial for effective Python programming, especially when handling immutable data or returning multiple values. By mastering list comprehensions and leveraging the versatility of tuples, you can enhance your Python programming skills and streamline your code. Join us as we explore these concepts and unlock the full potential of these powerful tools. We'll explore the power of Python dictionaries. Dictionaries are a fundamental data structure that allows us to store information in key-value pairs. Unlike lists or tuples, dictionaries are unordered collections that offer flexibility and efficiency in managing data. Let's dive into some key facts about dictionaries. A dictionary in Python consists of items stored as key-value pairs, created using curly braces. Each key is unique and immutable, commonly using strings, numbers. Today, we are embarking on an exploration of using dictionaries in Python, delving into the fascinating world of dictionaries and sets. Let's begin with dictionaries. In Python, dictionaries are key-value pairs, where values are accessed using their corresponding keys. For example, accessing key 1 in mydict will return value 1. Adding new items is simple by specifying a new key-value pair like new key with new value. Updating values is done by assigning a new value to an existing key, such as key 1 with updated value. Removal of items can be achieved using the del statement or the pop method, like del mydict key 1 or mydict.pop key 1. Dictionaries can also contain other dictionaries as values, allowing for the creation of complex data structures. Moving on to sets, they are unordered collections of unique elements in Python, meaning no duplicate values are allowed. Sets can be created using curly braces or the set function. They are mutable, enabling changes to their content after creation. Unlike lists, sets do not have a specific order, and items cannot be accessed by index. Python sets are versatile data structures that help manage collections of unique items, perform mathematical set operations, and efficiently remove duplicates. Creating a set can be done using curly braces or the set constructor. Adding elements to a set is achieved using the add method, while removing elements can be done with remove or discard, which does not raise an error if the element is not found. Python sets offer various useful methods for set operations, such as removing duplicates from a list or finding common elements between two lists. In our exploration of dictionary comprehensions, we focus on creating dictionaries in a concise and Pythonic way. Dictionary comprehensions, introduced in Python 2.7 and Python 3.0, follow a similar syntax to list comprehensions, enhancing code readability and efficiency by reducing the number of lines. Moving forward to defining classes, we delve into object-oriented programming, emphasizing classes and objects. Understanding how to define classes is fundamental for structuring code effectively, leading to robust and scalable Python applications. Attributes and methods are essential components in defining the state and behavior of objects in Python programming. Mastering attributes and methods is crucial for creating reusable and well-organized code, enabling effective coding practices and the development of complex systems. Inheritance and polymorphism are core concepts in object-oriented programming that promote code reuse and flexibility, resulting in efficient and maintainable code in Python. Join us as we explore the power of inheritance and polymorphism in Python programming, delving deeper into classes, objects, and their functionalities. Today, we delve into encapsulation and abstraction, exploring access modifiers and the concept of encapsulating class data. Encapsulation promotes data hiding, safeguarding an object's internal state from unintended alterations. It facilitates the creation of a clear interface for interacting with objects, enhancing code maintainability and readability by governing data accessibility and permissible operations. Thank you for joining us on this educational journey through the intricacies of Python dictionaries, sets, classes, objects, and the principles of object-oriented programming. Stay tuned for more insights and knowledge on mastering Python programming concepts. Classes in object-oriented programming serve as a blueprint for creating objects, encapsulating data and methods for data manipulation. Each class instance comprises attributes and methods defined by the class. Let's consider access modifiers through a practical example. By encapsulating data with access modifiers, we control the visibility and accessibility of data within our classes. Now, let's shift our focus to abstract classes and object-oriented programming. In the realm of encapsulation and abstraction, we explore how to implement abstract classes and methods in Python. Abstract classes are instrumental in defining common interfaces for subclasses, ensuring the implementation of specific methods in those subclasses. This approach fosters reusability and adaptability in design. In programming, abstract classes contain one or more abstract methods, which are methods declared without an implementation. These methods must be implemented in any concrete non-abstract subclass, thus enforcing a contract for the subclasses. Abstract classes are used to provide a base for subclasses, ensuring consistency and providing common functionality. Let's delve into some important concepts. 1. Abstract Base Class, ABC. In Python, the ABC module provides the infrastructure for defining abstract base classes. 2. Inheritance. Subclasses inherit the properties and methods of the abstract class and must implement any abstract methods. 3. Polymorphism. Abstract classes facilitate polymorphism, allowing objects of different subclasses to be treated as objects of the abstract class type. Understanding and using abstract classes is vital for learning Python programming, as it strengthens foundational concepts of OOP, encouraging best practices in software development, such as modularity and scalability. Moving on to interfaces in Python, focusing object-oriented programming, specifically encapsulation and abstraction. Let's explore how interfaces are used and their importance in programming. In Python, the concept of interfaces can often be related to abstract base classes, ABCs, and protocols. These define a set of methods and properties that a class must implement without specifying how those methods are implemented. Python's ABC module allows for the creation of abstract base classes, ABCs, with abstract methods that must be implemented by derived classes. Additionally, Python supports protocols introduced in version 3.8, allowing the definition of interfaces that can be implemented by various unrelated classes. Python's ability to handle multiple inheritance further enhances its flexibility in supporting different class structures. We delve into the world of Python interfaces. We explore how Python allows a class to inherit from multiple base classes, including interfaces, through practical examples. We showcase the use of abstract base classes to define interfaces explicitly, as well as duck typing to define interfaces implicitly. Additionally, we demonstrate implementing a protocol using typing protocol. Understanding interfaces in Python is essential for writing clean, maintainable, and flexible code. By leveraging abstract base classes, duck typing, and protocols, developers can define and utilize interfaces in diverse ways, promoting polymorphism and aligning with design principles like the SOLID principles. Lastly, we tackle advanced topics in file handling, specifically reading and writing files in Python. When a file is opened in Python, it becomes associated with a file object that enables a range of operations. We delve into key concepts such as file modes and context managers. Through examples, we illustrate the practical aspects of file handling, providing insights into efficient file manipulation techniques. We explore different file reading and writing methods, providing a comprehensive understanding of file operations. We demonstrate code that opens example.txt for reading and displays its content on the console. Additionally, we showcase code that creates or truncates output.txt and writes hello world to it, along with code that appends specified text to output.txt in append mode. Master the art of file handling with our insightful discussion. Working with JSON is crucial for Python programmers as it enables data manipulation and the creation of applications that handle persistent data. JSON, short for JavaScript Object Notation, is a lightweight data interchange format that is both human-readable and machine-parsable. It plays a vital role in web applications for facilitating data exchange between clients and servers. Key facts. 1. JSON is widely supported across various programming languages, including Python, making it a versatile data interchange format. 2. JSON data consists of key-value pairs, allowing for nested data structures. 3. Python provides built-in functions for parsing JSON data into Python objects and converting Python objects back to the JSON format. Let's consider an example of loading JSON data. Python import JSON, JSON data equals name Alice, age 30, data equals JSON loads JSON data, print, output. Python name Alice, age 30. JSON's simplicity and flexibility make it a powerful tool for data manipulation in Python. Stay tuned as we delve deeper into working with JSON in Python. Next, we explore dumping JSON data by importing JSON and converting it to a JSON string. Understanding how to work with JSON is essential for Python programmers in today's data-driven world, whether developing web applications, working with APIs, or managing data storage. Error handling is a critical aspect of programming that allows developers to manage and respond to errors during program execution. Effective error handling in Python can significantly enhance the reliability and robustness of applications. Key facts and concepts. Exceptions play a vital role in error handling. The try-except block is used to catch and handle exceptions. Handling errors gracefully improves code robustness. For instance, in a try block, if we attempt to divide 10 by 0, a zero division error exception will be raised. In the except block, we can handle this error by displaying a message like, "You cannot divide by 0." Thank you for tuning in to our podcast on error handling. Stay tuned for more insightful discussions on Python programming techniques. Error handling in Python is a fundamental aspect of programming that ensures the smooth execution of code and enhances the reliability of applications. By utilizing try and except blocks, developers can catch and handle exceptions gracefully, preventing program crashes. The finally block is essential for executing cleanup actions, regardless of whether an exception occurs, maintaining the integrity of the program. Intentionally raising exceptions using the raise statement allows developers to signal unexpected events, such as invalid inputs, by specifying custom error types like value error. Subclassing the exception class enables the creation of custom exceptions tailored to specific application requirements, enhancing error management and clarity in code execution. Understanding error handling principles is paramount for building robust and user-friendly applications in Python. By effectively managing errors, developers can optimize code performance and maintainability, ensuring a seamless user experience. Embracing error handling practices empowers programmers to identify and resolve issues efficiently, contributing to the overall quality of software development. Moving on to web development with Flask, a lightweight Python framework designed for building web applications with ease and flexibility. Flask simplifies the process of defining routes using decorators, enabling developers to map URLs to Python functions effortlessly. The framework's support for HTTP request handling and response generation streamlines web application development, allowing access to request data and customization of responses for clients. Flask's modular structure, facilitated by blueprints, enhances project organization by dividing applications into manageable modules. Error handling in Flask is robust, offering developers the flexibility to customize error pages and manage exceptions effectively. With its emphasis on simplicity and freedom of choice in tools and libraries, Flask provides a versatile platform for creating web applications tailored to specific project requirements. Practical examples in Flask demonstrate the creation of basic applications, integration of templates using Jinja 2 for dynamic content generation, and implementation of RESTful APIs for data exchange. Mastering Flask equips developers with valuable skills for web development, enabling them to craft efficient and scalable applications for diverse purposes. Transitioning to web scraping with Beautiful Soup, a Python library for parsing HTML and XML documents to extract data from websites. Web scraping is a powerful technique used for data retrieval, research, and analysis, streamlining the process of collecting information from web pages efficiently. Beautiful Soup simplifies the extraction of text, links, and images from web content, adhering to robots.txt guidelines for ethical data scraping practices. By exploring practical examples in web scraping, developers can learn to navigate mail structures, parse content, and make HTTP requests to retrieve specific data from websites. Mastering web scraping with Beautiful Soup enhances Python programming skills, enabling automation of data collection tasks and opening up opportunities for data analysis and research projects. In conclusion, Mastering API development in Python is essential for software engineers seeking to facilitate seamless communication between applications. APIs establish rules and protocols for data exchange, supporting operations like create, read, update, and delete to enhance functionality and interoperability. Authentication methods such as API keys, OAuth, and JWT JSON Web Tokens play a crucial role in controlling access to APIs, ensuring secure and reliable data sharing between software systems. Stay tuned for our next episode, where we delve deeper into API development using Python, exploring the intricacies of building and consuming APIs for diverse applications. API development is a vital skill for Python programmers, empowering them to create scalable applications and seamlessly integrate with other services. Prioritizing API development while learning Python will not only enhance programming skills, but also unlock numerous opportunities in software development. Thank you for listening to the Quiznek.com podcast. Go to Quiznek.com or download on the App Store to explore and create more educational topics.